because temperature is the degree of hotness or coldness of the body. It is the property of an object which determines which way heat energy will flow when it is placed in contact with another object. And heat always flows from a body at the higher temperature to another to a low temperature. So heat always flows from a body at the high temperature to low temperature. We can distinguish between heat and temperature. So there is that heat is a form of energy. When a body absorbs heat without changing its state, its temperature rises. So heat energy also depends on the mass of the body and its temperature. So let's define heat as a measure of the total internal energy of the body. It's a form of energy due to the temperature difference, whereas temperature is the degree of hotness or coldness of the body, and it is related to the energy of movement. It's the temperature of the average kinetic energy of the molecules of the body. Unit of heat is joules, while unit of temperature is degrees Celsius or Kelvin. Now let's talk about the temperature. There are different apparatus and devices used for measuring temperature. Our sense of touch can also give us a general impression, but for us to have a reliable and accurate measure of measuring temperature, we need these thermometers. So thermometers are instruments used for measuring temperature. Number one of them is liquid in glass thermometer. So its the thermometric substance is mercury or alcohol. Now, thermometric substance is basically that substance that is used to measure temperature, which has a property that varies with increase and decrease in temperature or generally change in temperature. So in this thermometer, the thermometric substance is mercury or alcohol because their volume is directly proportional to the temperature, or they exhibit properties which are proportional to the change in temperature. So then we also have the gas thermometer, which the thermometric substance is a gas, and it depends on the change of pressure at the constant volume with temperature. Then next we also have resistance thermometer. It is consisting of resistance wire. It depends on the change in electrical resistance with temperature. We have the thermocouple, which consists of two dissimilar metals. It also depends on the change in electrical potential difference between two metal junctions at different temperatures. Finally, we have the bimetallic thermometer. It consists of two dissimilar metals, and the thermometric property here is the differential expansion of the two metals of the bimetallic strip. We cannot understand temperature without talking about the upper fixed temperature and the lower fixed temperature points. Now, these upper fixed points and lower fixed points, they are defined in terms of the of water. So basically, the upper fixed point is the temperature of steam from pure water boiling at a standard atmospheric pressure of 760 millimeters of mercury. So basically, what this means is that the temperature at which water boils at standard pressure and temperature. So basically, next we have the lower fixed point. It is the temperature of pure melting ice at the standard atmospheric pressure of 760 millimeters of mercury. So these are things, that concept that we are going to use when we are talking about the calibration and the conversion from one thermometric scale to another. So this is called the fixed temperature and the temperature scales of thermometers. When we talk about temperature, we have different scales which are used. For example, we have the Celsius scale, we have the Fahrenheit scale, and we have the absolute or thermodynamic Kelvin scale. Now, each of these scales, they have their relative um, thermo, um, thermodynamic or rather calibrations. So they are calibrated different ways. So we have in this diagram, you can see that 212 degree Fahrenheit, it corresponds with 100 degrees Celsius, which also corresponds with 373 Kelvin. So these are their scales and the relative height and relative values. So this is the Fahrenheit intervals, which ranges from 32 degrees Fahrenheit to 212 Fahrenheit. Then the Celsius scale ranges from 0 degrees Celsius to 100 Celsius, and finally the Kelvin scales ranges from 273 Kelvin to 373 Kelvin. So these are from the upper fixed point to the lower fixed point. That is the range. That is called the fundamental interval. So, but they also range much more. For example, you can measure very much higher temperatures like 1000 Kelvin, 1000 degrees Celsius. But when we talk about the fundamental interval between the upper fixed point and the lower fixed point, we can compare these scales. Now, what if we were asked to determine the upper fixed point of an unmarked thermometer? So you can also always determine that by using a hypsometer, which is a double-walled copper vessel constructed as shown. So you have a manometer, a double-walled copper vessel, and you have boiling water below it. Then you have a thermometer. Then you have a steam outlet. So almost the whole length of the thermometer hangs fully in the steam of the inner chamber, well above the boiling water, and it is placed in such a way that its mercury thread is just visible above the top of the cork. So a manometer is attached to the inner chamber of the hypoxometer to ensure that the pressure within it is 760 millimeters of mercury. This is so when the mercury levels in both arms of the manometer are the same. Now, we also to the vessel, we attach a steam outlet to ensure that no steam condenses on the thermometer. Then the water is heated until it starts boiling. When the thermometer has been in the steam for some time and the position of the mercury thread has remained steady, the level in the level of the steam is now marked. The level of the stem um, of the thermometer is marked by a light scratch, and this mark is the upper fixed point of the thermometer scale. And you have to take some precautions here. For example, you have to ensure that the bulb of the thermometer does not come in contact with the boiling water. So, and also the thermometer should be suspended only in the steam. And you're also careful of making sure that you take the correct reading of the upper fixed point of the thermometer. Now, just as we can use an apparatus to look for the upper fixed point of a thermometer, we can also use a similar apparatus to look for the lower fixed point. So you just place the thermometer upright in pure melting ice contained in a glass funnel as shown. So when the mercury level remains steady for some time, a mark is made on the stem of the thermometer to indicate its level. So this represents the lower fixed point. So this experiment and this setup is based on the fact that when you have an arrangement like this, the boiling point of, or rather the melting point of a pure substance, assuming it is pure water, if the melting point of that pure water will be, or rather ice, melting point of pure ice with no impurity will be at a fixed point. So ice melts at a fixed point. So you can easily recognize this on a thermometer by looking for that temperature that is constant for some time before it changes. So the thermometer will read the same temperature until all the ice melts. So that is because of the latent heat and all sort of other phenomena like that. Now, one special type of thermometers we'll be dealing with in this section of this video is liquid in glass thermometer. There are different types of liquid in glass thermometer. There is a mercury thermometer, alcohol, and so on. But yeah, we'll be dealing with one special type which is known as the clinical thermometer. It is the form of mercury in glass thermometer that is used in hospitals for measuring the temperature of the human body. And the temperature of a normal healthy human is about 37 degrees Celsius, but it may rise to 41 degrees in case of high fever. So the reason for this, because of this, the temperature range of clinical thermometer is between 35 degree and 43 degrees Celsius, because that is the range of the possible temperature of a human body. Now the thermometer has a small bulb made of a thin glass, and the bulb has a narrow bulb through which a fine mercury thread moves. So this is the diagram here. The fine bore of the two makes it possible for small temperature changes to cause large changes in the length of the mercury column. So what this means is that the tube has a very tiny diameter. So the fluid here is not very thick. The thickness of the fluid is not much because of the tiny diameter. So because of that, the expansion is much more noticeable. And the most prominent feature of thermometer is the kink or constriction of bulb near the bulb. So you can notice this in the diagram where you can see a curve of the scale on the left. So it's called the constriction. Now this constriction allows the expanding mercury to flow past it when the thermometer is placed in contact with the human body. The mercury thermometer therefore remains in position in the upper part of the capillary tube when the thermometer is taken away. So when it flows past it, when it's taken away, it will still be at the level, so you can be read at leisure. So the thermometer can be read at leisure, so you don't have to read the scale on immediately. You can read the temperature scale at leisure. So that means the mercury column is supported by that kink. So basically the thermometer has a small temperature range, so you shouldn't sterilize it in boiling water, so that can actually destroy it and due to excessive expansion. So I hope you understand how a clinical thermometer works. Next time you visit the hospital, when you see it, you know how it works. Now let's talk about another type of liquid in glass thermometer, and this is called the combined maximum and minimum thermometer. It's a type of liquid in glass thermometer that is used by weathermen in meteorological stations, and it records both the maximum and minimum temperatures for the day. So the one in common use is the sixes combined maximum and minimum thermometer invented by James 6. So it consists of a U-shaped stem connected to two large bulbs, P and Q. Now in this case, both bulbs contain alcohol which are separated by a column of mercury in the bend. So while the alcohol in P is completely fills the bulb, in Q there is some air space near the top of the bulb. So two steel indexes I1 and I2 float in the alcohol in both sides of the tube, and temperature scales are provided against each limb of the U-tube. So how this works? This works by an increase in temperature causes the alcohol to expand. As a result, the steel index X1, the steel index I1 is pushed upwards. So when that steel index is pushed upwards, its lower end indicates the maximum temperature. This reading, this being read from the scale, decrease in temperature causes the alcohol to contract. So mercury moves up the minimum arm and pushes the steel index upwards. So the lower end of this index indicates the minimum temperature, and that's how it works. Then tiny springs in the two indexes help them to remain in the position to which they have been pushed. So a magnet is used to reset the index by bringing them in contact with the mercury column once more. So this is how it works. It's used by one arm measures the minimum and another arm measures the maximum temperatures. Next we have another type of thermometer called the gas thermometer. And because of these gas thermometers, we have a lot of accuracy in measurement of temperature, because mercury in glass thermometers are not very suitable for extremely accurate measurement of temperature. This is because of the fact that the glass also expands with temperature in an irregular manner. So also, such thermometers have a relatively small range determined by the freezing and boiling points of mercury, which are minus 39 degrees Celsius and 358 degrees Celsius respectively. But on the other hand, gas thermometers are actually used for accurate measurement, and the principle of the gas thermometer is based on the fact that at constant volume, the pressure of a gas increases linearly with the increase in temperature. So what we are measuring here is the pressure. So a constant volume gas thermometer consists of a large bulb which contains a gas such as hydrogen or helium, and the bulb is connected to a narrow glass tube attached to a pressure or rather attached to a mercury manometer. So when the gas in the bulb is heated to a particular temperature, the gas expands and pushes the mercury down in bulb into B and up into A. So in this case, the expansion of the glass is negligible compared to the glass expansion. The gas is kept at a constant volume by moving the manometer up or down to bring the mercury level on the B side to a fixed mark E. So basically, the pressure of the gas is then read from the manometer. So and that pressure is the difference. The level of mercury in A is above that in B. So that means the gas pressure in the atmosphere plus the difference in the level of pressure is the pressure of the gas. But if the pressure of if the gas level, if the mercury level in the left arm is actually greater, that means the atmospheric pressure is greater than the gas pressure. So the pressure of the gas in the bulb is related to the difference in the mercury levels of the manometer. So if you want to calibrate the thermometer, you just need the gas pressure when the bulb is placed in pure metal ice. So you measure the gas pressure, and then you also measure when it is steam, and then you plot this against the graph, and then you get a straight line which passes through, and this graph can be used to read off the accurate temperature values for measured pressure reading. So basically the advantage of this is that it is very sensitive and it is very accurate, consistent, and has a wide range. But the disadvantage of this is that it is large and cumbersome and is not suitable for measuring the temperature of small volume of liquid or small enclosures. It also requires the knowledge of the pressure of gas at a fixed point anytime we require to use the instrument. Now finally, let's talk about the resistance thermometer. Now in this case, this thermometer operates on the fact that the electrical resistance of a metallic conductor is proportional to its temperature. So that means that the higher the temperature, the greater the resistance. So it consists of a long thin platinum wire wound around a small spool made of mica or silica. So basically, the ends of the wire are connected to a resistance measuring the device, such as a Wheatstone bridge. And if, for example, a given platinum wire has a resistance of RO at 0 degree and R100 at 100 degree, then the temperature T when its resistance is R is given by R minus RO over R100 minus RO times 100, that's degrees Celsius. So in many cases, the resistance scale is calibrated to read the temperature directly in degrees, and the resistance thermometer are useful in accurate measurements of very low or very high temperatures. So that's because they are made up of metals which can withstand high and low temperatures, and also the resistance of such metals give a linear property. So the scale is easy to calibrate. So basically, this resistance temperature is also as accurate as the gas thermometer, and this is where we'll stop for the temperature scales. I thank you all for staying up to this extent in this video. And finally, we are going to talk about the exercise for this video. And the exercise here is it on the screen, is being displayed on the screen. You can also try it, and you can forward your answers to the WhatsApp number in the description of this video. I hope to see you next episode. Thank you.